Hello and welcome to this new video. In the previous video, we implemented the join system of a dedicated server. So, we implemented the processes of unregistration and registration of players in the session. In this video, we will continue our work on the management of a dedicated server. What we will discover, therefore, is the management of the life cycle of the dedicated session, as well as the management of the dedicated match. The first thing to do is to allow clients to leave the dedicated match and return to their lobby. To do this, go to the World 2 widget, then add the on-clicked event of the Leave Match button. To leave a dedicated match, it's simple, just call the Master Controller Interface function, Leave Session on the client side. To get the dedicated session the player is in, you can get it from the current session of the game instance. Remember that we updated this variable of the game instance when joining a dedicated server in the previous video. As a reminder, the implementation of Leave Session in the Master Player Controller destroys the session on the client side, then sends the player to his lobby. Return to the game mode of World 2. What we want to do, we want to start the management of the life cycle of the dedicated session. For the moment its state is pending following the creation. Because the current configuration of the session does not allow the join in progress, it means that once the session is started, no client can join it, and therefore to join the dedicated match. What we will do therefore to give a delay to the game mode, it will therefore wait for the connection of the players before starting the session. For me, once the session is started it means that the match has started. So add a function and name it f_wait for players. This function will be called by a timer to check that the dedicated server has the minimum number of players to be able to start the match. Create a variable of type integer and name it max number of players. This variable represents the maximum number of players that the dedicated server can host. The default value of this variable must be the same number of maximum public connections of the session. In my case, it is 20. Create another variable that represents the timeout for waiting players' connections. If the current number of players is less than the max number, we must wait for other players to connect. If the current number is equal to the maximum number, we can then proceed to the process of starting the session. Because I'm in a dev mode, and I have only 3 players, I'm not going to wait for 20 players to connect, so I want to set a condition that the match can start if the current number is greater than 1, while keeping a timeout to wait for the other players to connect. If we reach the maximum number, we can reset the timeout variable. The same if the current number is 0. So we start the waiting for player timeout if and only if there is at least one player in the match. I will set a timeout of 10 seconds, so if the timeout is reached and we have at least one player in the match, we start the session. We must define the timer which calls this function continuously in the on-post login, so when we have at least one player connected. Promote this timer to variable to have a reference to it. We must initialize the timer only once, and not at each connection of a player. So we must verify that the timer is not valid before initializing it. We must clear and invalidate the timer before calling the start session process to avoid calling start session in an infinite loop. If you want to update the timeout variable by increment, you must define a time of 1 second between each iteration of the timer. Otherwise, the timeout time will not be real. What I want to do is to add the time I defined to the timer, so 0.1 to the current value of the timeout variable. So I have to change its type from integer to float. If the timeout is reached, we must reset the value of the variable to 0, then invalidate the timer. We will start the implementation of the script that starts the session. You can do it by implementing the master game mode interface. But I prefer to go through a custom event and a macro in case of dedicated server, as I have already done for the session creation and update processes. So add a custom event which is used to start the dedicated session. We must verify that the session is valid before proceeding. Again, it is not very important to do the verification because a dedicated server does not remain for life if the session is not created and therefore valid. Call Easy OSS Task, start OSS session, then connect the session name. Open your master game mode. We will add an event dispatcher which is triggered if the start process is failed. If the start process is complete, call the event dispatcher on start session complete, and call on start session failed otherwise. Return to the function and call the start session event if the number of players has reached the maximum number, or if the timeout is reached with at least one player. If the number of players is 0, we never wait for players, and therefore the session will remain in the pending state. This is useful if the timeout process started with a player, but this player left the game before the end of the timeout. In this case, the timer will be invalidated and the dedicated server will wait for a new connection to restart the timeout process. This value must be 0 and not 1. Finally, it depends on your game and how many players you plan to start the session. To run a test, print to log the value of the timeout variable when the server triggers the waiting process. Launch an instance of a server and a client. Join the dedicated server from player 1. As you see, when a client is connected, the server has started the timeout process to wait for other players before starting the session. And that's it. When the timeout is reached with at least one player, the session has been started by the server. Start a new server instance, then try to join its session, and leave the match before the timeout is reached. And there you have it. When the server is waiting for players but the number of connected players goes back to 0. The server invalidates the timer and waits for a new connection from a player to start the waiting process again. Rejoin the session and watch how the server will start the waiting process again. And there you have it, everything works as it should. Return to game mode. In fact, we can use the macro that we have already created in the macro library, which is used to start the session instead of implementing the start process in game mode. The advantage of this macro is that it respects the life cycle of a session, so the session only starts if it is in pending state. We must now assign the two event dispatchers on session started and on session start failed in the begin play event of the game mode. These binds will be necessary to know when we must end the session and subsequently destroy it. If the start process fails, we have to kill the server. But I will give it the opportunity to try the start process several times before deciding to kill it. This is the same process we did when the creation process fails. So add a custom event that will be called when the onStart session failed event is triggered. As we did for the session creation failure, add a new integer type variable which represents the number of start process attempts. Copy these nodes and then paste them into our custom event. On each attempt, wait 2 seconds, then call the start process, and increment the attempt variable afterwards. Now call this event when the failure delegate fires. If the start process is executed successfully, we must wait until the end of the match before deciding to end the session and then destroy it. So what I want to do is create a custom event that will be called when the session is started. This event will wait for the end of the match using the delay node, then at the end it will end the session. You can set a delay according to your game mode and your game. What I want to do is create a variable representing the match time, then connect this variable to the delay node. Once the match is over, I will call the macro end session. Again, add an event dispatcher in master game mode that triggers in case of session ending failure. Now call both event dispatchers according to the macro return status. I want the call to the end session process to be independent, so I want to move the implementation into a custom event dedicated to the end session process. Don't forget to call this event when the session is started after the delay. Again, assign the two events dispatchers of end session process in the game mode begin play event. Same, if the end session process is failed, I will try to call it several times before deciding to kill the dedicated server. So it will be the same implementation in case of creation and starting failures. create a new variable representing the end attempt. Call the process of ending session. Now call this event when the failure delegate fires. If the end session process is executed successfully, we will destroy the session and kill the server. So add a custom event which is used to code this implementation. Remember that the destroy macro directly destroys the session. It doesn't matter because we respect the life cycle of the session in our game mode. We will do the same again. Add the event dispatcher which is triggered when the destroy process fails. Now call both events dispatchers of destroy session process according to the status returned by the macro. In fact, there is no need to call the event dispatcher if the destroy process executes successfully. We can directly proceed to the request engine exit. In the begin play event, assign the event dispatcher when the destroy process fails. In this case, you can implement a retry system. Personally, I don't see the point of doing it. We can kill the server. Anyway, When the server is killed, the session will be destroyed by the backend, except that it can take a few minutes. I want to increase the timeout of waiting players, so that I can test my game with several players before the match started. We should call the timer that waits for players to connect only if the session state is pending. There is no need to enter the waiting process if the match has started. So call the easy OSS node, get OSS session state, to obtain the current state of the session. We therefore proceed to the waiting process if the current state is pending. I forgot to call the destroy process once the session went into ended state. I'll do it. We will test our implementation. Launch a dedicated server instance and several client instances. Join the dedicated server session from players 1 and 2. Wait for the wait process to start the session. Once the session is started, player 3 cannot join it, because the session does not allow join in progress. We can clearly see in the portal that the session is now in started state. Then once the match time is reached by the server, the session will therefore be ended and then destroyed and the server is killed. We see that both players are still in the match. This is normal because a connection error is currently in pending state, so they will be sent back to the default game map in 60 seconds. We will see and manage this in the next video. And there you go, they are sent back to the default game map due to a connection timeout with the server. That's all for this video. See you in the next one.